Hello, Martin. Martin, are you able to hear me? You can write in the chat box. Hello, Martin. Hello, Hamna and Martin. Are you getting my voice? You can use the chat box also. Beta, are you getting my screen? Hamna?
Hello, sir.
Hello. Is there any problem?
No, I'm okay.
Hmm?
I'm okay. No problems.
And Hamna?
Yes, sir.
Beta, I am just asking, and you are not responding. You can just write in the chat box. Okay. In the last class, we have discussed the how to calculate the power in correcting the hypermetropia and what is hypermetropia, Martin?
Not able to see far things, right?
Not able to see what
Like
things?
distant, like
Distant
distant.
object.
Yeah, distant. Not distant. I mean near. Hyper. Which one? Hypermetropia, right?
Yeah,
Yeah,
hypermetropia.
not near objects.
The person is not able to see the nearby objects. And how to correct that hypermetropia? To use a convex lens. To use a convex lens. Okay. So earlier we have discussed the myopia. And what is myopia? Myopia is the eye defect in which the person is not able to see distant object clearly. And how we correct myopia? By using a concave lens. By using a concave lens. So there is one more defect that we will discuss today: presbyopia. Presbyopia. Okay. So basically, presbyopia occurs in the old age. In that old age, what happens? The ciliary muscles becomes weak, so there is a dysfunctioning in the eye lens. Okay. So dysfunctioning in the eye lens, so there is a problem for maintaining the power of accommodation. Okay. So we can write in old age, due to ciliary muscles becoming weak, and eye lens becoming inflexible, inflexible. So the eye loses the power of accommodation, power of accommodation. So because of that, an old person cannot see the nearby objects, nearby objects clearly. This leads to the defect called presbyopia. So basically, what happens in old age? The eye lens become inflexible because of the old age, and the ciliary muscles becoming weak. Due to that, the power of the accommodation, okay, loses the power of accommodation. Okay. So basically, the power of the eye lens becomes less. So when the power of the eye lens become less, due to the due to the eye lens become inflexible or uh, weak ciliary muscles, Okay, so what happens due to that? The focal length of the eye lens increases. Okay, focal length of the eye lens increases and the power decreases. Okay, and to see the nearby object, the eye lens should have the large power. So in that age, eye loses the power of accommodation, and due to that, he or she in old age cannot see the nearby objects clearly. Okay. So there is one more defect that is known as the cataract. So basically, cataract is a condition, medical condition in which there is a layer on the surface of the eye, white color layer on the surface of the eye. Due to that, there is a blurred vision. Okay. So what is cataract? The medical condition in which the lens of the eye becomes cloudy. Okay, due to formation of layer, or you can say membrane, due to the formation of membrane over it, resulting in blurred vision. Vision is called cataract. Called cataract. So what is presbyopia? Presbyopia occurs in the old age in which the ciliary muscles becomes weak and the eye lens becomes inflexible. Due to that, the power of accommodation is lost, and the old person is not able to see the nearby object clearly. What is cataract? In case of the cataract, on the eye there is a formation of the layer, formation of the membrane over the eye, due to which the eye is not able to see clearly the object. Okay, so this is the presbyopia, this is the cataract. And myopia, in myopia the person is not able to see the distant object clearly. In hypermetropia, the person is not able to see the nearby objects clearly. So basically presbyopia is something similar to the hypermetropia, and the correction of the presbyopia is same as that of hypermetropia. We use the convex lens. Okay, and for the uh, solution of this cataract, okay, to treat the cataract there is surgery, and different things are there. Okay, in medical science. So basically surgery is preferred for reducing the cataract, or for removing the cataract. Basically in cataract, what the doctors do, remove that layer formation from the eye by operating. Okay, now after this we will discuss the glass prism. Glass prism. So before the glass prism, we have seen the refraction. We will discuss the glass refraction by the glass prism. Okay, before that I want to tell you, this is a glass slab. This is a glass slab. What is this? This is a glass slab. This is the glass slab, and we know that I have told you the refraction through the glass slab earlier. So in case of the glass slab, see, this is the incident ray. This basically This thing is a glass slab. This thing is a glass slab, and this is the incident ray. This is the incident ray, and suppose here is air. This incident ray is coming from the air, and this glass slab is made up of the glass. And finally, here is air. So what happens? Refraction takes place. I have told you how the refraction takes place. This incident ray, and there is another ray. There is another ray. This ray. This ray is known as the emergent ray. This ray is known as the emergent ray. Emergent ray. So basically you can see this incident ray and the emergent ray from the refraction of the glass slab are parallel. Incident ray and emergent ray are parallel. Okay. So you can see here, this is the incident ray and this is the normal, this is the angle of the incident. Okay. So as air is a rarer medium, glass is a denser medium. So light ray is moving from rarer to denser, it will bend towards the normal like this. Okay. Bend towards the normal like this. So here, when the light ray will strike, so this is the normal. So from here, the light ray is moving from glass to air. From here, the light ray is moving from glass to air. So light ray is moving from denser to rarer. So light ray will bend away from the normal. Okay, so this is the angle of emergence. Angle of emergence. So basically, this will be the emergent ray. Final ray coming out of the glass slab will be the emergent ray. So this emergent ray and incident ray are parallel in case of the glass slab. Okay, so we can write here, in case of glass slab, in case of refraction through glass slab, through glass slab, incident ray and emergent ray are parallel. And why the incident ray and emergent ray are parallel? Because the surfaces of the glass slab are parallel. Opposite surfaces. This surface and this surface are parallel. Okay? Because the opposite faces are parallel. Because opposite faces, suppose this is the face F1, this is the face F1, and this is the face F2. So these faces are parallel because opposite faces are parallel. So that is why the incident ray and the emergent ray are parallel. But now we will discuss the glass prism. We will discuss the glass prism, and first I will describe what is the glass prism, and after that we will discuss what will be the condition of refraction through the glass prism, and will the incident ray and the emergent ray will be parallel in that case or not. We will see that. Okay, so glass prism. So basically this is a glass prism. In lab, I think you have seen. Martin, have you seen this in your lab?
Yes, sir.
And Hamna, have you seen this in your lab? Yes or no? Okay. So basically, see, this is a glass slab. So basically, what is happening here? This is a white light, and this phenomena we will discuss later. Okay. So basically, I want to show you what is the glass slab. So this is the glass slab. So what is a glass slab? Glass slab is a transparent object made up of glass. Okay. In which there are two triangles and there are three rectangular ends. Three rectangular sides are there. Okay. So how we represent the glass slab? In this is the representation of the glass slab. On copy or on paper, we represent the glass slab like triangle. Okay, so this is the representation. How we will represent? So basically, this will be the representation. Suppose this is PQR. So PQ on copy, we will represent the glass slab like this. Okay, uh, what I am saying, glass slab, glass slab. This is a glass prism. Okay, this is a glass prism. This is a glass prism. So what is this? This is a glass prism. So this is the representation of glass prism. Okay. So this is the representation of glass prism. So on copy or on paper, we represent the glass prism like triangle. So basically, this is a triangular glass prism. Okay. This is a triangular glass prism. Triangular glass prism. Now we will see. Now we will see the refraction through this glass prism. Okay. We will see the refraction through this glass prism. Refraction through triangular glass prism. Triangular glass prism. So basically, this is a triangular glass prism. And this is a triangular glass prism, PQR. And a light ray is like this. A light ray is entering like this. This is a light ray entering. Now, this is a light ray entering. So, this is the face of the prism. This PQ is one of the face of the prism. You can see here. Basically, prism, this face is like this. Okay. So, light is entering on one face, and on this face, there will be the normal. Okay. So, I am drawing the normal to this face. Suppose this is the normal. This is the normal. This is the normal. So what will happen, as here is air and this light ray is going from air to, this is the glass. Okay. Basically, here will be the glass medium, glass medium. Here will be the air medium. So air is the rarer and glass is the denser. So light ray is going from rarer to denser. It will bend towards the normal. So the light ray will be like this, something like this. Light ray will be something like this. Bend towards the normal, then it will be something like this. Okay. Like this it will be. And if you want to see the original path of the light ray, then original path of the light ray will be this. This will be the original path of the light ray. Okay, now at this point there will be the refraction. This is the normal, suppose. So now you can see here, this is the glass and this is the light ray. From this point, the light ray is entering into the air again from the glass. So glass is a denser and air is a rarer. Here is the air. So light ray is moving from glass to air. Then it will bend away from the normal. So this is the normal. So it will bend away from the normal like this. Bend away from the normal like this. Somewhat like this. Okay. So this will be basically the emergent ray. So this is the incident ray. This is the emergent ray. Now see the angle between the incident ray and the emergent ray. Suppose this angle is theta and this theta is the angle of deviation. Angle of deviation. Now you can compare the refraction through the glass slab and refraction through the glass prism. See the incident ray and the emergent ray not parallel. The incident ray and the emergent ray are not parallel. Okay. Incident ray and the emergent ray are not parallel. Okay. So this thing you have to remember. This is the path when there will be no refraction of light. Okay. Suppose here is the meeting point of this is O. So you can see here the incident ray and the emergent ray are not parallel. Why this is happening? Because of the shape of the glass prism. This phase PQ and PR are not parallel. Okay, the phase PQ and PR are not parallel. That is why there is some deviation in the incident ray and the emergent ray. Okay, so with respect to the incident ray, the emergent ray is not parallel. So you can write here in refraction through the glass prism. Through the glass prism. Emergent ray is not parallel to incident ray. Parallel to incident ray. Why? Because the opposite phases are not parallel. Because the opposite phases, the opposite faces are not parallel. You can see here this phase PQ and QR are not parallel. That is why this incident ray and emergent ray are not parallel. Write down Matthew and Hiba. Hamna, what is your name? Hamna and Abdullah and Martin. Write down. Hello Abdullah, how are you?
Yeah, fine, sir.
Abdullah, so this is presbyopia basically, and this is cataract. So please write down it.
Okay.
Okay, Martin and Hamna, please write down. Then after that, I will discuss what is the dispersion of light. Abdullah,
Yes, sir.
from where you are?
I am from India.
Okay. Okay, write down it first. Completed, Martin, Hamna. Oh, Hamna completed. And uh, Abdullah completed.
Yes.
Okay, so write down this fast. Write down this and make the diagram also. They can ask you in the exam that why in a glass prism the emergent ray is not parallel to the incident ray, but in case of the glass slab the emergent ray is parallel to the incident ray. So you can answer it like, because in case of the glass slab opposite faces are parallel, but in case of the glass prism opposite faces are not parallel. Write down it. And there is no need to draw this, and you cannot draw this. This is just the example I have shown here so that you have the better understanding of glass prism. So what is f1 and f2 are the opposite faces. I am writing here f1 and f2 are opposite faces. Martin, got it?
Yes, sir. F1 and F2, right?
Yeah, F1 and F2 are the faces here. Like this. One face of the glass slab, another face of the glass slab. Both are parallel. But in case of the prism, Hamna, got it? Okay, beta. And Abdullah,
Yes, sir.
got it now?
Yes, sir.
If you have any doubt, then you can ask me, no problem.
Sir, no doubt, sir.
Martin, when completed, you can ask me to scroll down, okay?
Yeah, done, sir.
Okay, so what you have to do now, just wait a minute. How to draw this on the copy. So you will draw the triangle like this, okay? And you will say this is the representation of triangular glass prism. Okay, so no need to you cannot draw this also, you cannot draw this also, so draw this diagram. Okay, so now you can write this. This is basically the incident ray and this is the emergent ray, and this PQR is a glass prism. You can say simply prism. Completed, Hamna? And Martin?
No, sir.
Okay, Martin. And Abdullah, you can take your time. No problem. But at least when completed, you should tell me. Because I am not watching you that whether you have completed or not. Okay? So understand the concept properly. Okay? The concept of refraction we are using here. Refraction is taking place here. When the light ray travels from rarer to denser, then it will bend towards the normal. Whenever the light ray travels from denser to rarer, it will bend away from the normal. What is the meaning of the refraction? Refraction means whenever light rays traveling from one medium to another medium, like light rays traveling from water to air or air to water, or glass to air or air to glass, or glass to water or water to glass, oil to glass or glass to oil. Okay, between two medium when light ray travels. And why there is a bending in refraction? Because in different medium the light speed of the light is different. That is why there is a deviation. Light changes its path. Why? Because speed of the light in different medium is different. In air it is 3 into 10 to the power 8 meter per second. In glass it will be less than that. Martin, now completed?
Yes.
Okay, okay. After this, we will discuss dispersion of light. So basically, first complete, then I will tell you what is dispersion of light and who has had discovered the dispersion of light and what is dispersion of light we will discuss.
Yeah, done, sir.
Done, okay. So now we will discuss dispersion of light. Basically, here what is happening? Here this is the incident ray, and initially it is in air, and now it is in glass. After moving to the air, at this point, this ray is entering to the glass, and as there is a different speed of light ray in air and different speed of light ray in glass, so there will be the bending of light. There will be the bending of the light ray. That is known as the refraction of the light. Okay. Now at this point, the light is leaving the glass and entering the air. So that is why here is bending. So basically, in the year 1665, There was a scientist, Newton, Isaac Newton. So he discovered that by his experiment with the prism. So he took a prism and he passed a white color light. White color light means a sunlight or light of a bulb is a white colored light, we say. And he find that the light is that white color light is made up of 7 colors. Made up of 7 colors. So basically, this is the dispersion of light. See here. This is the experiment done by the Newton. So basically, a beam of the white light is there, or this is the sunlight, or this is off, but here it will be or. Okay, sunlight or white light or bulb light. It will be or. Okay, or bulb light. It will be passed from the prism. Then this pattern you will see. And what is this? This is the screen. This is the screen. So a white light is passing from the prism, and due to the refraction, see, different colors are there on the screen. Red, orange, yellow, green, blue, indigo, violet. So basically the white light will split into 7 colors. So white light will split into 7 colors. And why this is happening? Because from this experiment, it is found that white light is made up of 7 colors. 1, 2, 3, 4, 5, 6, 7 colors. So basically, and why there is a least deviation for the red color, and why there is a maximum deviation for the violet color, and why, if I want to say that, why there is different deviation for different color. This is because there is a different amount of refraction for the different colors. And why there is a different amount of refraction? Because different colors of white light have different speed in the same medium. So basically, okay, basically you can say that in the glass prism, when the colors, basically white light is made up of 7 colors. So basically 7 color will traveling in the glass prism. So this, all the 7 colors will have the different speed, and that is why they have different amount of refraction or different amount of deviation. That is why there is a least deviation for the red color and the maximum deviation for the violet color. Okay, so what is the dispersion of the light? Splitting of light into the 7 colors when passing through a glass prism is known as the dispersion of light. Okay, so we will write here what is dispersion of light. So basically a white light is passing from the prism. See the phenomena, and this is the screen on which all the colors are there. A band will be formed. Okay, a band will be formed on the screen. So basically, what is the dispersion of light? The splitting of white light into 7 colors on passing through a transparent medium, through a transparent medium like triangular glass prism, like glass prism, is called dispersion of light, is called dispersion of light. Okay, dispersion of light. So basically, what colors we are getting? Red, orange, yellow, green, blue, indigo, violet. So basically, there is a term you can Vibgyor. Okay, Vibgyor, Gyor. Okay, so this is the Vibgyor. So V for violet, I for indigo, blue, green, yellow, orange, red. So you can remember this word. Okay. Vibgyor. So remember this. So basically, from when you will move from red color to the violet color, when you will move from the red color to the violet color, red to the violet, when you will move, wavelength will decrease. Okay, wavelength of the color will decrease. Wavelength decrease. So it means that we can say the wavelength of the red color is maximum. Okay, and frequency increase, and frequency increase. So now can Martin Hamna, what is your name?
Yes, sir.
Hamna, tell me which color has the maximum frequency? I am asking to Hamna. Peter, tell me. Just see, when you are moving from red to violet like this. Very good. Okay, very nice. So basically, this violet color will have the maximum frequency, and now Martin will tell which color will have the maximum wavelength.
Oh, violet.
No. See here, wavelength is decreasing, na? When you are moving here to here. Okay, I am writing that.
So red.
Red color will have the maximum wavelength. Okay, so this red color will have maximum wavelength. Remember these points here. And this violet color have the maximum frequency or minimum wavelength. Minimum wavelength. So which color will be least deviated? Red color will be least deviated. Okay. So what is the meaning of the Vibgyor? You can just learn this as like this. But you will remember that least deviated will be the red color. Okay, the pattern will be like this: red, orange, yellow, green, blue, indigo, violet. But just in case that you have forgotten, so you will use this Vibgyor. But you will remember red color will be the first color. Okay, when you will draw this diagram. So V for you know, I for you know. Okay, you can write here. Want red, orange, yellow, orange, yellow, green, blue, indigo, violet. Okay. And what is the reason why these colors are deviating to different amount? Martin, can you tell me?
No, what, sir?
Just I am asking why the this red color is deviated least? Why the violet color is deviated maximum? What is the reason behind that?
Mm.
I have told you na that different color will have different speed in the same medium,
Yes,
and
sir.
different color will have different amount of refraction. Okay, so the amount of refraction for the red color is least. That is why this is least deviated. Okay, amount of refraction for the violet color is maximum. That is why it is maximum deviated. Okay, so we can write here reason also. Reason different colors deviated differently. You can write here deviated to different angle of deviation. So I am writing the reason. So the amount of refraction or bending depends on the speed of the colored light, speed of colored light in glass, since different colors travel since different colors travel with different speed in glass, so they are refracted through different angle. So they are refracted through different angles. Okay, so you can say some colors deflected least, that is red, and some colors deflected maximum, that is violet. Okay, so this is the reason. So red color is least deviated, violet color is the. Okay, so write down, try to draw this. Okay, so after that we will wind up this class and we will meet in the next class. Please write down first, all of you, Amna, Martin, and Abdullah. Okay, copy this, Martin. Try to draw this. First, draw the triangle and draw the light, and you can just split this white light into 7 color. Okay, and after that, draw a screen here and try to show red, orange, yellow, green, blue like this. Okay.
Yeah, dance. Yeah, dance.
Martin, when completed, please ask me to scroll down. Martin completed.
Yes, sir.
Abdullah completed. Okay. Okay, write down. Abdullah, are you writing? Completed, Martin?
Almost.
Okay. Have you understood now why different colors have different deviation?
Because it have different speed, right?
Because every color will have the different speed, okay,
Okay,
of
sir.
moving in the medium, and refraction is depending upon the speed.
Yeah, done, sir.
Okay, Martin, so we will meet in the next class. Okay,
Yeah, thank you, sir.
and if you have any doubt, then you can ask me, no problem.
Okay, sir.
It's all fine.
Yeah, fine, sir.
Okay, so we will meet in the next class.
Okay, thank you, sir.
Okay. Hello, Abdullah. Completed?